Good to see you, curious minds. Two open standards just quietly changed the future of artificial intelligence, and most people haven't heard of either. One was born at Google, the other at Anthropic. And now, both sit under the same Linux Foundation umbrella, building what might be the most important infrastructure layer in AI history. Together, they have over 110,000 GitHub stars, 150 supporting organizations, and SDKs in 15 programming languages. Every major cloud provider, Azure, AWS, Google Cloud, has adopted them. There's already a payments protocol built on top with 60 financial institutions signed up. If you're building anything with AI agents, or plan to, you need to understand what A2A and MCP actually do, how they work together, and why the entire industry just agreed on this. Stack. Let me walk you through it. Here's the situation as it stood in early 2025. You could build an AI agent that used tools. You could build an AI agent that talked to a database called an API, or search the web. But you couldn't build two AI agents from different companies running on different frameworks that could talk to each other. Every integration was custom. Every connection was a one-off. If your travel agent needed to talk to your hotel agent, someone had to write a bespoke bridge between them. And if you wanted to swap one agent for another, start over from scratch. The industry had a word for this: point-to-point integration. I have a better word: chaos. Think about what this meant in practice. A hospital using an AI diagnostic agent from one vendor couldn't connect it to a treatment planning agent from another vendor without months of custom engineering. A supply chain company couldn't let their inventory agent negotiate with a logistics agent from a different provider. A financial services firm couldn't have their risk assessment agent collaborate with a compliance agent built on a different framework. There was a workaround, of course. You could wrap an agent as a tool, pretend it was just a function call using something like MCP. But that's fundamentally limiting. Agents aren't tools. Agents reason, plan, maintain state, negotiate, engage in multi-turn dialogue. Wrapping an agent as a tool is like hiring a surgeon and telling them to only use a hammer. You're stripping away everything that makes an agent an agent. The problem needed two solutions. One for connecting agents to tools, that's the vertical integration problem, and one for connecting agents to each other, that's the horizontal collaboration problem. That's exactly what we got. And the fact that both solutions ended up under the same open governance body is what makes this story remarkable. Let's start with MCP, the Model Context Protocol. Created by Anthropic, specifically by David Suryapara and Justin Spar-Summers, now under the Linux Foundation. MIT license for the specification, Apache 2.0 for the server implementations. Think of MCP as the universal plug. Just like USB-C standardize how every device connects to every peripheral, regardless of manufacturer, MCP standardizes how every AI application connects to every tool, data source, and workflow. The analogy isn't marketing fluff. It's architecturally precise. Here's how it works. There are 3 roles in the MCP architecture. The host, that's your AI application, like Claude, ChatGPT, VS Code, or Cursor. The host coordinates one or more MCP clients. Each client maintains a dedicated connection to exactly one MCP server. And the server is the program that exposes tools, resources, and prompts to the client. MCP servers expose 3 core primitives. First, tools executable functions, API calls, database queries, file operations, shell commands. Your agent discovers available tools via tools/list and invokes them via tools/call. Each tool has a name, description, and input schema. Second, resources, data sources providing context. File contents, database records, API responses, real-time data feeds. Resources are discovered via resources/list and read via resources read. Third, prompts, reusable interaction templates. System prompts, few-shot examples, structured workflows. Prompts are discovered via prompt/list and retrieved via prompt/get. The transport layer is elegant in its simplicity. For local tools running on the same machine, there's STDIO, standard input, and lightweight fast, no network overhead. For remote services, there's streamable HTTP with server-sent events for real-time streaming. Everything runs on JSON RPC 2.0, a well-understood, battle-tested protocol. The lifecycle is clean. Initialize version negotiation and capability discovery. Initialize notification. Client ready signal. Then tool, resource, and prompt discovery and execution. Real-time notifications when things change. Tools list change tells the client that available tools have been updated. Now, the numbers tell the story. 86,500 GitHub stars on the server's repository. 1,600 forks on the spec repo. 10,900 on the server's repo. 4,153 commits on the specification alone. 10 SDKs, C#, Go, Java, Kotlin, PHP, Python, Ruby, Rust, Swift, and TypeScript. Every major AI client supports it. Claude, ChatGPT, VS Code, Cursor, MCP Jam, and dozens more. There's even a dedicated registry at registry.modelcontextprotocol.io. And here's the thing that makes MCP genuinely powerful. It's bidirectional. Servers aren't passive tool providers. They can request LLM completions from the host through a primitive called sampling, and this is model independent, meaning the server doesn't need to know which LLM the host is using. They can request user input through elicitation, asking the human for confirmation or additional context. They can send structured logs back to the client for debugging and monitoring. The server is an active participant in the conversation, not just a function endpoint. Now here's where it gets genuinely interesting. Google and Anthropic, two fierce competitors who are simultaneously suing each other and partnering with each other, are now both under the same Linux Foundation umbrella for these protocols. That's how serious this is. When your competitors agree on infrastructure standards, you know the infrastructure matters. A2A, the agent-to-agent protocol, was proposed by Google in April 2025 and just hit version 1.0.1 on May 28, 2026. That's 14 months from proposal to production-ready stable release. 24,000 GitHub stars, 2,400 forks, 570 commits, 150 supporting organizations, up from 50 at launch. That's triple growth in 1 year. A2A solves the problem MCP deliberately doesn't touch. How do independent agents collaborate as peers? The architecture is a 3-layer model. Layer 1, the canonical data model, protocol-agnostic structures, tasks, messages, agent cards, parts, and artifacts. Layer 2, abstract operations, the core verbs of agent collaboration. Send message, send streaming message, get task, list tasks, cancel task, subscribe to task, plus push notification CRUD operations and get extended agent card. Layer 3, protocol bindings, JSON RPC 2.0 over HTTP, gRPC, or plain HTTP plus JSON REST. You pick the binding that fits your infrastructure. The discovery mechanism is where A2A gets genuinely clever. It uses agent cards, JSON metadata documents published at a well-known URI, typically .wellknown/agent card. Think of it like a business card for your agent, but machine-readable and cryptographically verifiable. An agent card describes the agent's identity, its provider, its capabilities through agent skill definitions, its service endpoint, and its authentication requirements. When your agent needs to find a collaborator, it reads, agent cards. No central registry needed, no authority to register with. It's decentralized discovery, the way the web was designed to work. Version 1.0 added cryptographic signing to agent cards. That means your agent can verify the identity of the agent it's talking to using digital signatures. In a world where agents will be making decisions and transactions on your behalf, that's not a nice to have. It's essential. There's also support for extended agent cards, authenticated versions available only to authorized clients, for agents that shouldn't be publicly discoverable. The task lifecycle is stateful and long-running. A task moves through submitted, working, input required, completed, failed, canceled, or rejected. There's human-in-the-loop support built in. The input required state explicitly pauses the task waiting for human input. Multi-turn conversation patterns are handled through context IDs and task IDs. Real-time streaming via server-sent events delivers task status update event and task artifact update event as they happen. Push notifications handle disconnected scenarios. Your agent goes offline and catches up later via HTTP post to webhook URLs. The security model is enterprise grade. Security scheme types include API key, HTTP auth, OAuth 2, OpenID Connect, and mutual TLS. Multi-tenancy is supported. A single endpoint can host many agents. Version negotiation ensures old and new agents can coexist. There's even an IANA registered media type, application/A2A plus JSON, and custom HTTP headers, A2A, version and A2A, extensions, 5 production-ready SDKs, Python, Go, JavaScript, Java, and .NET. The steering committee reads like a who's who of enterprise computing. AWS, Cisco, Google, IBM Research, Microsoft, Salesforce, SAP, and ServiceNow. That's not just tech companies. That's the companies that run the world's business infrastructure. Remember when I said agents aren't tools? Here's what happens when you get that wrong. You end up wrapping a sophisticated reasoning system into a dumb function call. The entire industry just agreed that's the wrong approach. And here's the architecture that replaces it. MCP and A2A operate at different layers of the agent stack. MCP is vertical. It connects agents down to tools and data. A2A is horizontal. It connects agents to each other as peers. Picture this. You tell your AI assistant, plan an international trip to Tokyo for 2 weeks. Your orchestrator agent uses A2A to delegate to a flight booking agent, a hotel reservation agent, a currency conversion agent, and a local tours agent. That's horizontal collaboration. Agents talking to agents as peers, each maintaining their own state, reasoning independently, negotiating terms. Now, each of those agents internally uses MCP to access its own tools. The flight agent queries airline APIs through MCP tools. It reads fare databases through MCP. The tours agent pulls activity listings through MCP. That's vertical integration. Agents reaching down to their tools. The official documentation uses an auto repair shop example that illustrates this beautifully. A customer tells the shop manager agent about a rattling noise. That's user to agent via A2A. The manager delegates to a specialist mechanic agent to agent via A2A, with the mechanic maintaining its own diagnostic state. The mechanic runs a vehicle diagnostic scanner. Agent to tool via MCP, calling scan vehicle for error codes with the vehicle ID. The mechanic checks parts availability with a supplier agent to agent via A2A again, negotiating price and delivery time. Neither protocol tries to do the other's job. MCP doesn't orchestrate agent collaboration. It doesn't understand task life cycles, multi-turn negotiation, or agent identity. A2A doesn't manage tool connections. It doesn't understand function schemas, resource reading, or prompt templates. Together, they form a complete stack that the entire industry can build on without reinventing either layer. So what does this actually mean outside the architecture diagrams? For consumers, this is the infrastructure that will let your AI assistant actually book across multiple services. Not just search, book. Your Google agent talks to a Salesforce agent, which talks to a payment agent, which talks to a logistics agent. No single company owns the entire chain. Best-of-breed agents compose naturally. You get the best flight agent, the best hotel agent, the best restaurant agent, and they work together without any of them being built by the same company. There's already an agent payments protocol, AP2, built on top of A2A. 60 financial organizations are extending the standard for secure agent-driven transactions. That means your AI agent could literally authorize a purchase on your behalf with cryptographic proof of your consent. The payment flows through A2A's task lifecycle, with human-in-the-loop approval at the critical moment. For developers, this means no more vendor lock-in. Build your agent on any framework, LangGraph, Google ADK, BAI, and it can collaborate with agents built on completely different stacks. The agent card is the universal handshake. Your LangGraph agent can delegate tasks to a Salesforce agent, which delegates to an SAP agent, which delegates to a custom agent you built last Tuesday. The framework doesn't matter. The protocol does. For enterprises, the adoption is already production grade. Azure AI Foundry supports A2A. Google Cloud supports A2A, supply chain coordination across vendors. Financial services with agent-driven transactions. Insurance claims processing across organizations. IT incident management spanning multiple vendors. Healthcare diagnostic systems with multi-agent consultation. There's even a free deep learning AI course demonstrating this. Cisco's distinguished engineer called this the syntactic layer that makes agent-to-agent communication reliable, and said we're heading toward a planet-scale Internet of Agents. That's not hype. That's an engineer describing infrastructure. And here's what I find most compelling: the governance model. Both protocols are now Linux Foundation projects. That means no single company controls the standard. Google proposed A2A, Anthropic created MCP, but neither owns the future of either protocol. The steering committee includes their competitors. That's how open standards actually work, and it's rare in AI. A2A isn't the only protocol in this space. IBM has ACP, the Agent Communication Protocol. And there are older approaches: REST APIs, webhooks, gRPC, enterprise service buses. But the adoption numbers settled the debate. REST APIs are point-to-point. Every integration is custom. Webhooks are one-way with no state management. gRPC requires proto files and tight coupling between services. Enterprise service buses are heavy and centralized, the opposite of what agent architectures need. A2A is decentralized, web-aligned, uses agent cards for dynamic discovery, and has 150 organizations backing it. MCP has 86,000 stars and 10 SDKs. Together, they're not competing. They're completing each other. One for tools, one for agents. The stack is settled. Let me be honest about what's still early. A 2A version, 1.0, just shipped. Most production deployments are still in pilot phase. The agent ecosystem is growing fast, but the number of publicly available agent cards is still limited. Finding the right agent to collaborate with still requires knowing where to look. MCP is more mature, but the registry is new and discovery can still be manual. Security best practices are evolving. The spec is solid, but real-world attack surfaces are still being mapped. Prompt injection through MCP tools is an active research area. And there's a philosophical challenge that nobody has fully solved. When agents start making transactions on your behalf, who's liable? The AP2 protocol addresses some of this with cryptographic consent, but the legal frameworks are lagging the technology. If your agent books a non-refundable flight you didn't actually want, who pays? These are growing pains, not deal breakers. The foundation is solid. 2 protocols, 150 organizations, over 110,000 GitHub stars between them, and a clear architectural vision. MCP for tools, A2A for agents. If you're building AI agents today, this is the stack to build on. If you're evaluating AI tools, check whether they support both protocols. That's the best indicator they're building for the future, not just the present. The links to both specifications, the SDKs, and the Deep Learning AI course are in the description below. I'll see you in the next one. Off you go! But don't wander too far.